Hey learner, ready for some seriously weird physics? We're going deep into quantum mechanics, where the universe kind of bends the rules of reality. And we've got a stack of research papers to prove it.
Yeah, these aren't your average physics papers either. We're talking quantum decoherence, Wigner's friend, even if true randomness exists.
Whoa, hold on. Before we break reality completely, maybe we should set some boundaries.
Yeah, good idea.
So our mission is to make these crazy complex ideas, well, not so crazy. We want to explain these concepts clearly, no jargon allowed.
Exactly.
So by the end of this deep dive, you'll actually understand how scientists are trying to figure out, the very nature of time, reality, and how much we can even know about it all.
Basically, how much the universe lets us in on its secrets.
Right, exactly. So how about we just jump right into it? Yeah. Let's start with this paper, 1508.05377 VA2.pdf. It's all about how gravity messes with our understanding of time.
Okay, so imagine time just flowing, past to future. This paper says that gravity, especially at the quantum level, could be like a bigger player in how time flows than we ever thought.
So it's like controlling everything.
Kind of, yeah. They even use the term non-renormalizable gravity, which basically means gravity at this super small scale doesn't really care about our equations. Like it's saying, I play by my own rules.
It's like gravity just ditched physics class one day.
Yeah, and decided to make its own rules. Think of it this way. You have quantum mechanics, where everything likes to be in its place, nice and organized.
Right.
Then you've got gravity, warping space and time.
Shoes causing chaos.
Totally. And the paper suggests all this pushing and pulling from gravity might be a big reason why time can only move forward.
So basically, thanks to gravity's rebellious streak, we can't rewind our lives. Man,
It really makes you think, huh?
it does. It really does. But speaking of mind-blowing stuff, let's move on to another brain twister, shall we?
Let's do it.
This next paper, 1902.050 VECDU-V2.pdf, is all about something called Wigner's friend.
Ah, yeah.
It's this thought experiment that's about as strange as it sounds.
It's a classic thought experiment for sure, but a good one. It really gets you thinking about the role of observation in, creating reality.
Okay, so how does it work?
So picture a single photon of light, like the absolute smallest bit of light you can imagine. And this photon exists in multiple states at the same time, which we call superposition.
Okay, that already sounds kind of wild.
Right. Now imagine your friend is watching this photon. What Wigner's friend asks is, does watching it force the photon to choose just one state? And what does that even mean for, well, reality itself?
Whoa, okay, I think I get it. So it's like the universe is saying, pick a lane photon, but only if someone is looking.
Yeah, exactly. And to actually test this, researchers recreated Wigner's friend in a lab. They used some really complex technology, things like fusion gates and superconducting nanowire single photon detectors to basically build this tiny obstacle course for these photons to go through.
So like a microscopic Olympics for photons.
Pretty much. And what they found was even at that incredibly small scale, just the act of observing seemed to actually influence what the photon did.
No way, seriously.
Seriously, it suggests that just looking at something, observing it, might be way more powerful than we thought, maybe even shaping the reality that we experience directly.
So you're saying reality is shy.
Yeah.
If we don't look at it, it can be its weird self.
That's one way to put it. But this experiment really makes us question if objective reality, something that exists without an observer, is even possible. It challenges, the foundation of how we understand the universe.
Talk about a deep dive. This is heavy stuff.
It is.
Maybe we should lighten things up a bit.
Sounds good.
How about we tackle something a bit more, random? Is anything truly random? That's what this paper, 2004.0897883.pdf, tries to unpack.
Most people think of randomness like flipping a coin.
Right.
But actually proving something is truly random, not just a pattern we haven't figured out yet, is really hard.
Yeah, it's like trying to predict what chaotic masterpiece my sock drawer will produce every morning.
Exactly. That's where this thing called Kolmogorov complexity comes in. It's a way to measure randomness based on how much information something has in it. So imagine trying to, compress a random jumble of letters versus compressing a full sentence.
Okay, I'm with you.
The sentence, which has structure and meaning, you can squish that down easier. But a truly random sequence, that's like trying to stuff a giant fluffy cloud into a tiny box.
It's not going to happen.
Nope. It just won't work.
So the less compressible something is, the more random it probably is.
Right. But here's the catch. This paper also points out that even if something looks random, it might just be a pattern we haven't cracked yet.
Ah, so frustrating.
Right. It's a good reminder that we don't know everything, and sometimes we can't tell the difference between true randomness and hidden order.
Makes you wonder if the universe is laughing at us behind the scenes.
Maybe. But speaking of things the universe likes to throw at us, what about those moments where everything seems connected? Like in a weird way. Have you ever felt that?
Like when you think about someone and they call you out of the blue? Or is that just me?
It happens to everyone. It kind of makes you think about this idea of global consciousness.
Hmm.
And this paper, Correlations of Continuous Random Data with Major.pdf, takes a look at that using data from something called the Global Consciousness Project.
Okay, that sounds intense. What is that exactly?
Basically, it's this network of random number generators all over the world, and they use these generators to see if really big global events, things that everyone is focused on, actually affect these totally random systems.
Hold on, you're telling me that when something huge happens in the world, these random number generators go haywire?
Well, not haywire, but they become less random. It's like the universe is trying to tell us something.
Whoa, that's wild.
Right. Now, it's super important to remember that correlation isn't causation. Just because we see a pattern doesn't mean one thing caused the other. But it does make you wonder if there's something like a connected consciousness linking us all together.
So you're saying We Are the World wasn't just a catchy song?
Maybe, maybe not. But if our collective thoughts can influence random number generators, what about our own individual thoughts? Can we directly affect the physical world around us just by thinking about it? Radon Physics Essays 2131.pdf goes there using the classic double slit experiment.
Ah, the double slit experiment, a classic. It shows how light can be both a wave and a particle.
Exactly. It's like the Swiss Army knife of quantum mechanics. But this paper asks, can our minds change how light behaves in the experiment? Can we make it do what we want?
That's like next level mind control.
Right. So researchers had people focus on the experiment and trying to mentally influence the outcome. And the result, well, they weren't totally clear, but they were super interesting. It hinted at a possible connection between what the participants wanted and how the light behaved.
So, like, our minds have a direct line to the quantum world.
Maybe. This paper, and others like it, open up this whole can of worms about how important consciousness is in shaping the reality around us. It makes us think we might not just be passive bystanders in the universe.
We might be running the show, or at least trying to. Well, on that note, why don't we take a break? Let all these mind-blowing thoughts sink in for a bit, and when we get back, we'll try to tie all these crazy ideas together. Stay tuned.
Right, so plasmas. Sounds kind of sci-fi, right?
A little bit, yeah.
But they're actually the most common state of matter in the whole universe. Think of stars, those giant balls of burning plasma.
So not just something from a lab.
Nope, they're everywhere. But this paper, Extraterrestrial Life in the Thermosphere, Plasmas, UAP, Pre-Life, Fourth State of Matter, it's focused on a specific kind of plasma called plasmoids. Imagine, like, a self-contained blob of plasma, almost like a lightning bolt, but with way more energy.
Okay, so a lightning bolt on steroids.
Basically. And some scientists actually think they might explain some of those weird lights we see in the sky, UAPs.
You mean UFOs?
Exactly. UFOs.
Whoa, okay, so not aliens, but maybe they're spaceships.
Not quite spaceships. This paper suggests that these plasmoids, which happen naturally, might actually be behind some of those unexplained things we see up there. They can move around in really strange ways and even light up.
So you're saying it's not aliens, it's just fancy plasma.
It could be, but it gets weirder. This paper also suggests that plasmas could be where extraterrestrial life comes from.
Wait, life from plasma? That's a whole other level of weird.
I know, right? It sounds crazy. But plasmas are super dynamic and they can organize themselves in really complex ways. So this paper is exploring the idea that maybe under the right conditions, plasmas could actually create structures kind of like cells.
So life, but not as we know it.
Exactly. It's a wild thought.
It really is. But okay, let's shift gears a bit. We've talked about outer space. How about we go inward to our own minds?
Sounds good.
This paper, S13423-01508-88.pdf, talks about the interface theory of perception, which is a pretty complex way of saying that our brains are basically filtering reality for us.
Yeah, it's like our brains are saying, look, you've got enough to worry about down there. I'll handle the really complicated stuff.
It's like our brains are the original Instagram filters, making reality look a little bit better than it actually is.
That's a good way to put it. This paper argues that what we see as reality isn't necessarily the full picture, but just the most useful information our brain thinks we need. Like, think about a computer desktop. You've got all those icons, right?
Right.
And those icons represent all sorts of files and programs, but you don't need to see all the code behind them to use them, right?
Right, that would be a nightmare.
Exactly. So this theory is saying that our brains might be doing the same thing, filtering out all the extra code and just giving us a simplified version of reality that we can actually handle.
So we're basically living in a simulation created by our own brains.
In a way, yeah. But it makes sense, right? Our senses evolved to help us survive, not to give us a perfectly accurate picture of reality. Sometimes that means taking shortcuts.
I guess that makes sense. Still kind of freaky, though.
For sure. But hey, as long as our brains are keeping the truly terrifying stuff hidden, I'm good with it.
Me too. But speaking of terrifying, let's talk about those moments where seemingly unrelated events just seem to line up perfectly. Okay, so we've gone through all this crazy stuff, quantum decoherence, plasma UFOs, even the idea that our brains are basically editing reality for us.
It's a lot to take in.
It really is. But where does it all connect? What's the big takeaway from all these mind-bending ideas?
Well, it's easy to think of these things as separate mysteries. But the really cool part is seeing how they all point towards these bigger questions about the universe and our place in it.
Like, we've been putting together a giant puzzle this whole time.
Exactly.
And one of those puzzle pieces, it seems like, is the idea of limitations. Limitations on what we can actually know for sure, how accurately we experience reality, even the tools we use to understand it all.
Right, like with randomness. This paper, the Design Inference Eliminating Chance.pdf, really digs into how tricky it is to define. We think about coin flips, but how do we know for sure something is truly random and not just a pattern we haven't figured out? That's where this idea of specification comes in.
Okay, hold on. Specification. That sounds more like something you'd find in a dictionary than in the universe.
Well, think of it like this. Imagine flipping a coin 100 times and it lands on heads every single time.
Pretty lucky streak, right?
Right. But is it random? You could say it's just a crazy coincidence, but what if instead of random heads, those coin flips spelled out a message? Or a mathematical formula?
Okay, that's way different.
Exactly.
Yeah.
That's specification. It's when improbable events actually fit into a pre-existing pattern. That's when you start to think maybe something more than just chance is going on here.
So, like, finding a secret message in a bowl of alphabet soup is way more mind-blowing than just random letters.
Exactly. It suggests intention, design, something more than just pure chance.
Wow. Okay, I kind of see where you're going with this, but how does that apply to, like, the entire universe?
Well, it makes you wonder, what if what we see as random, those cosmic coincidences, they actually have hidden patterns, a deeper order that we haven't been able to figure out yet? It's a pretty humbling thought. Like, maybe the universe is way more complex than we can even comprehend.
It's like the universe is playing a cosmic game of chess, and we're just tiny pawns.
Maybe we're not even on the board yet. We're still trying to figure out the rules, but that's the exciting part, right?
I guess so.
There's so much we don't know, and just like any good game, trying to understand the universe requires different players, different perspectives. That's another thing that connects all these ideas we've been talking about. We need physics, psychology, philosophy, all of it working together.
It's like we're trying to understand a giant elephant in a dark room. Each of these disciplines, they're just feeling a different part. And it's only by bringing all those individual perceptions together that we can even begin to see the whole picture.
And it's one heck of a picture, right? From those tiny particles to the vastness of space, we're starting to see connections we never even imagined before.
Right, like the plasmas. Who would have thought that those swirling clouds of charged particles could be the key to understanding UFOs and maybe even alien life? It's like something out of Star Trek.
It really is. But that's the beauty of science. It's always pushing the boundaries, questioning assumptions, and honestly, it's okay to be a little mind blown sometimes.
Totally. So, to our listeners out there, if you take away just one thing from this deep dive, let it be this. The universe is a lot stranger and more wonderful than we often realize. Our brains are constantly creating this filtered version of reality, so what we perceive isn't always the full story.
We've barely scratched the surface of understanding things like randomness, consciousness, and the nature of reality. But that's the exciting part. By embracing the unknown, by asking those tough questions, by looking at things from different angles, we can learn so much more about the universe and ourselves.
We might not have all the answers, but hey, that's what keeps things interesting. Keep those brains buzzing out there, and we'll see you on the next deep dive.